Hello everybody. I welcome you all to NCAS Geology class. Today I will discuss about the sedimentary process of origin of ore deposits. In my last class, I was discussing about the igneous origin of ores, and now I will discuss about the sedimentary origin of ores. Sedimentary ore deposits refer to the formation of mineral deposits by sedimentary process, which operates at or near the earth surface, including chemical precipitation, mechanical concentration, residual concentration, oxidation supergene enrichment, and biological activity followed by diagenesis. So these are the methods of sedimentary process of origin of mineral deposits. Mineral deposits, they originate by chemical precipitation, by mechanical concentration, by residual concentration, by oxidation and supergene enrichment, and through biological activity or through evaporation process. So these are the methods by which the sedimentary ore deposits are found to be concentrated, and they involve mostly the sedimentation process and the processes associated with the weathering, erosion, transportation and deposition of sediments, which can be called as the sedimentary processes. And by these processes, the ore deposits are being produced. And these deposits, sediment deposits, are mostly syngenetic because they formed along with the formation of the sediments. And in some cases, there may be epigenetic, that may be derived from the hydrothermal fluid or from the sedimentary brines derived from the oceanic environment, which intrude into the sedimentary formations, and there it gives rise to the deposits. Generally, the deposits can be called as sedimentary because during the sedimentation process or during the development of the sedimentary rocks, these ore deposits are developed in the sedimentary rocks. And broadly, the sedimentary ore deposits are classified into the following categories: the mechanical concentration or the pressure deposits, residual concentration, oxidation and supergene enrichment, and sedimentation process that involves either sedimentation or chemical precipitation, in which banded iron formations are originated, banded iron formations with algoma type or lake superior type. Besides that, we have the SIDEX deposits, Mississippi Valley type. So these are related to sedimentation. And besides this, we have this evaporation process, biogenic processes, which are also the sedimentary processes by which the ore deposits are being produced. So let us discuss these methods of origin of sedimentary or the sedimentary processes which involves formation of ore deposits one by one. The mechanical concentration, it is otherwise called as a process which gives rise to pressure deposits. Here, the resistance of the minerals to weathering, that becomes the deciding factor for the concentration of the minerals. The minerals which are highly resistant, which are heavy, which are durable, they are separated from the provenance and they are transported to the deposition, to the site of sedimentary deposition or to the environment of deposition by the agents of denudation. It may be running water, it may be wind, glaciers, or it may be waves, or there may be mass wasting process that will control the concentration of the resistant minerals that are separated during the weathering process from the provenance, and they are transported and localized along different sides of different suitable sites, such as the hill slopes, foothill regions, or in the beach, or along the meanders of the lakes, meanders of the rivers. So these are the suitable sites where the resistant, durable, heavy minerals separated from the provenance and transported by the agents of denudation are found to be concentrated. So here the source rock is important, or the provenance, where the valuable minerals are there and they have been removed from the source rock by weathering. And through weathering they are liberated from the source rock. Then they are transported by the agents of denudation. They are sorted gradually during the time of the transport, and they are subject to deposition in suitable locations. And their concentration in large quantity gives rise to economic mineral deposits, as we find in case of placer deposits of Gopalpur coast in Orissa, which are the beach placers containing the ilmenite, rutile, zircon, garnet, feldspar, selmenite. These are the beach placers, or the heavy minerals which are found in the beach sands. Beach sands associated with the Bay of Bengal in Orissa coast at Gopalpur. And beside this, there are also heavy mineral deposits at Kerala coast, such as monazite sands, and the golds, diamonds, platinum, magnetites, monazites, they are found to be produced through placer deposit. So placer deposit is a process of mechanical concentration of the heavy minerals in suitable locations, being sorted by the geomorphic agents, being sorted by the gravity, being favored by the slopes of the hills, being favored by the sedimentary environment, as we see in case of beach, in case of river meanders. So this is about the mechanical concentration deposits, which are the placer deposits. And in Orissa, these beach sands are being mined by the Indian Rare Earths IRE Limited. This is the company which is mining these mineral deposits, and the rare earth elements are being derived from these minerals. Now let us discuss residual concentration. Here it is a type of in situ deposit after removal of undesirable minerals from the rocks. So it can be called as a residual pressure deposit, and it develops in situ, in its own place, by chemical leaching of the undesirable minerals and concentration of the residual minerals as economic mineral deposit. As we see in case of laterite, it is found to be iron rich, derived from the basic igneous rocks. Basic igneous rocks are found to be rich with iron. Similarly, aluminous rocks, they give rise to bauxite, as we see in case of khondalites of Western Ghats. Khondalites rich in quartz, feldspar, garnet, sillimanite. So in this rock, the aluminous components are found to be concentrated after removal of the silica in solution. So chemical leaching of silica and concentration of alumina to form bauxite. Bauxite is a combination of three minerals: gypsite, boehmite and diaspore. These are aluminous minerals, and these components are found to be the residual part derived from the minerals which constitute the khondalites, as we see in case of Western Ghats. These are the aluminous minerals: quartz, feldspar, garnets, silvanides. So quartz is removed, silica components of feldspars, garnets, they are removed, leaving behind the alumina that forms bauxite. Bauxite is a economic mineral, becoming mineral for aluminium. Similarly, laterites, they are rich in iron. So laterites, bauxites, they are called as residual. They are found to be considered by residual process because the associated minerals are removed, leaving behind the residues which form the economic mineral deposit. So it involves the process of formation of this residual mineral deposit involve chemical weathering of effective rocks over a long time, leaching of the silica and other minerals which are not to be concentrated, and the minerals which are to be concentrated are left behind in situ, and they give rise to economic mineral deposit as we find in case of concentration of aluminum oxide, Fe2O3 to form bauxite, laterite. And to facilitate the above process, the topography should be favorable, it should be plateau-like, climate should be hemotropical type so that deep chemical weathering is possible, and there should be leaching, and leaching can be favored if proper drainage is available in the highlands. So these are the conditions which are necessary for formation of these residual mineral deposit as we see in case of bauxite deposit of Orissa, associated with the east coast in the Khandaritic terrain in the plateaus of Western Ghats. For example, Pottangi and Panchpatmali bauxite deposit of Odisha. In Koraput district. So they form the residual concentration deposits. Besides this, we have other methods of origin of ores by sedimentary process. These are oxidation and supergene enrichment. Here sulfide minerals are being produced. The process of mineral deposit gives rise to metallic sulfides in the zone of reduction below the water table. It takes place when the sulfide minerals present in the zone of oxidation above the water table are affected by chemical weathering and they are converted into sulfates. The sulfates trickle down from the zone of oxidation to the zone of reduction, and the sulfates undergo precipitation in the zone of reduction through the reaction to the hypogeum sulfide minerals, and there occurs a enrichment of the sulfides in the zone of reduction, and it gives rise to supergene sulfide enrichment zone below the water table in the zone of reduction. And the process involves, I can say that pyrite, if pyrite is present, this initiates the process. Pyrite reacts with oxygen, water to form iron sulfate and sulfuric acid. This sulfuric acid again attacks other sulfide minerals present in the zone of oxidation. Iron sulfate gets converted into ferric sulfate with reaction with water and oxygen. It becomes ferric sulfate and ferric hydroxide. Ferric hydroxide is the limonite, and this limonite forms the Goshan on the top. Goshan serve as the signboard for mineral deposit in the zone of reduction in form of major sulfide deposits. So the copper sulfates solution which is being produced in the zone of oxidation that goes down, trickles down from the zone of oxidation to the zone of reduction. The hypogeum minerals are there such as PBS and other sulfides. With them, the sulfates they react, they give rise to the sulfides from these sulfates which enrich the zone of reduction, because these components are derived from the zone of oxidation and they are found to be precipitated in the zone of reduction. So that thing has been discussed here. Metal sulfates trickle down into the zone of reduction, precipitate sulfides through their reaction with the hypogeum sulfides. So hypogeum low grade sulfide zones get enriched with more sulfides derived from the zone of oxidation, and it produces a zone of supergene enrichment rich with metal sulfides. And if we further go down, we trace the hypogeum sulfides zones which are not economic. This is not economic, but this zone becomes economic, which is the supergene enrichment zone of sulfide minerals, as we find in case of Singbum copper belt. This type of deposit is found. So this process involves formation of sulfides in the zone of reduction, where hypogeum sulfide minerals are there, produced by the earlier igneous process. That igneous minerals are found to be enriched by the secondary process of precipitation through their reaction with the sulfides, with the sulfates that trickle down from the zone of oxidation into the zone of reduction. That thing has been explained here. So besides this, we have other processes of origin of the sedimentary rocks. For example, sedimentation or chemical precipitation. This is another method which includes the formation of banded iron group of rocks. They are of two types, lake superior type and Algon type. Algon type represents the Archean origin of iron, and lake superior type it is Precambrian origin of iron ores. Besides this, we have the sedimentary axial deposits involving the formation of sulfides in the sedimentary horizons, in the ocean, in the continental platforms, the stable continental platforms. And we have the Mississippi Valley type, which is not associated with any igneous activity, but these are associated with igneous activity. So let us discuss these banded iron formations which involve sedimentation and chemical precipitation of ores in the sedimentary environment. So what is banded iron formation? Here the iron deposits are found to be in banded form, and these deposits developed during the Archean time or in Paleoproterozoic or Precambrian time in the sedimentary basins, which span in age from 1.8 billion years to 2.5 billion years or more than that. The genesis of banded iron formation involves the following. So how the iron ores are being produced in the sedimentary environment? It was produced in the following way. The iron was released into the sedimentary basins from submarine volcanism or from weathering, leaching of continental rocks. So this iron may be land derived, may be derived from the submarine volcanism, and they are brought to the sedimentary basin. It may be ocean basins. The Precambrian oceans were initially anoxic. They are not rich with oxygen. That's why reducing environment was prevailing in the Precambrian oceans, and there iron, ferrous iron was in solution. Then shallow water photosynthesis by cyanobacteria led to rise in oxygen level in the seas of the Archean time, and it made the oceans to be oxic, which is described as the great oxidation event. As a result of which iron dissolved in the seawater became ferric iron, and this ferric iron got precipitated to form iron oxides, and its precipitation took place rhythmically with precipitation of silica, as a result of which banded iron formations developed in the sedimentary basins or in ocean basins. The iron minerals are hematite, magnetite, and silica are jasper and chert. So in this way, the iron ore deposits developed in the sedimentary basins through sedimentation and chemical precipitation. And these banded iron formations are divided into two types. One is the Algoma type, the other is the Lake Superior type. Let us discuss about them. Lake Superior type. It originated in the late Archean or Paleoproterozoic time over the stable continental platforms or on cratonic basins. The main source of iron to the environment of deposition was submarine weathering of the continental crust with little or no contribution from the submarine volcanism. So the iron is land derived, continent derived. It may be submarine weathering of the continents because the cratons they got drifted from the sedimentary basin, and in that basin weathering, removal of iron from the continental rocks contribute towards the iron concentration in the sea that developed over the cratonic basins, cratonic areas. So there occurred the alternating precipitation of silica and iron producing banding, and the banding was due to seasonal or cyclic variation of oxygen supply, biological activity and chemical precipitation, EH and pH condition of the depositional environment. These conditions favored the rhythmic precipitation of iron followed by silica, iron, silica. That's why banded iron formations developed in the sedimentary basin, and this gave rise to rhythmic precipitation. Rhythmically precipitation was due to the seasonal variation, biological activity, cyclic variation of oxygen supply, EH pH condition of the depositional environment. These factors contributed towards the rhythmic precipitation of iron and silica in form of layers, and they provided large scale lateral continuity, and they account for the world's largest source of iron ore deposits in the iron ore deposits. This type of banded iron formation is found to be best developed in the Lake Superior region of North America, from which the naming has been derived, and other basins are Hammersley Basin of Australia, Minas Gerais deposit of Brazil, Kursk region of Russia, Transvaal Basin of South Africa. In India, we have the Noamundi Joda belt in the Keonjhar, Orissa, Koila Dela, Chhattisgarh basins, Dali Rajara area, Kudramukh area of Karnataka. These are the sites where we find thick accumulation of the banded iron formations belonging to Precambrian age. And they represent the world's largest deposit of iron. And beside this, we have the Algoma type. It is a metasedimentary iron ore deposit found in Archean rocks, more than 2.5 billion years of age, or they are found in greenstone belts. Here, the hematite and magnetites are found to be interbedded with volcanic rocks. So they are associated with volcanism. Volcanism provided the iron-bearing solution that got interbedded with grey wax, sedimentary rocks, turbidites and pelagic sedimentary rocks. So the source of iron and silica are found to be hydrothermal fluids derived through the submarine volcanism or volcanic hot springs. These components get precipitated in downward sedimentary basins around volcanic centers contemporaneously with the volcanic activity and sedimentation in the deep abyssal basins. So volcanism was taking place in the sedimentary basins. Into these volcanic materials are added. So there is interbedding of the deposits, iron, silica, iron, silica, iron, silica. So complex mixing of this hydrothermal fluid with the sediments, and in this process the hematites and magnetites got precipitated in the sedimentary rocks. So they are found to be interbedded with, the volcanic rocks are found to be interbedded with gravox or pelagic sedimentary rocks. And these are of Archean origin. They are not found to be continuous as it is found in case of the Lake Superior type, and they are found in the cratonic areas and associated with the volcanism. The iron sediment derived from the igneous source, and it gets mixed with the sedimentary rocks in the basins. Example, Abitibi greenstone belt of Canada, Singhbum greenstone belt, Jharkhand. So we have the greenstone belts which are iron bearing, such as Dharwan greenstone belt, Karnataka, Shimoga Chitradurga belt, Bababudan Kudremukh belt. So in the cratonic basins there might be sedimentary origin, there might be igneous origin. The sediments may be land derived, giving rise to the Lake Superior type, and there may be volcanism in the same basin with formation of Algoma type deposits. So Algoma types are found side by side with the Lake Superior type. So in the same Kudremukh basin we find the Lake Superior type, and in the same basin also we find the Algoma type. As we find in Orissa, we have the Joda Bodbil sector, that is the Algoma, that is the Lake Superior type, Jodamundi Bodbil area. It is a part of the iron ore group of rocks. Iron ore group. So iron ore group is dominant in the Singhbum craton. So this is part of the Singhbum craton. So they occur side by side, depending upon whether they are the iron is land derived or it is derived from the igneous intrusives. So Algoma type is igneous, Archean in age. Lake Superior type is sedimentary, having the sedimentary source of origin of iron, and it is extensive deposit banded with showing continuous banding. And this is the major difference between the Lake Superior type and Algoma type. Geological age here in case of Superior type it is Precambrian, here it is Archean. The environment is stable continental shelf here in case of Superior type. Here it is volcanic arch or greenstone belts. Volcanism is absent in case of Superior type. Volcanism is present in the Algoma type. Aerial extension is very extensive, in regionally continuous in case of Superior type, and limited occurrence, localized, lenticular. The thickness is very high in case of the Superior type. Thickness is not that high, it is moderate, thin and variable. In case of Superior type, the rock types associated are the quartzites, shales, carbonates, And in case of algon type, the basalts, below lavas, tubes, they are the associated host rocks. Sulfide minerals are rare in case of the lake superior type, the lake superior type, and it is common in case of the algon type because it is derived from the volcanic eruptions or from hydrothermal fluid. So it is pyritic, pyrotitic. The iron is pyrite bearing and pyrrhotite bearing sulfides. So iron minerals are here hematite, magnetite, and in case of algonite it may be magnetite plus minus hematite, but it is intimately associated with sulfides, iron sulfides. And silica phase is charged just per, in case of algonite it is charged. So the chemical precipitation takes place in open marine basins, that is in case of lake superior type, and in case of algon type it is lancet and strata bound related to hydrothermal volcanic activity. This thing has been explained here. It is land derived, in lake superior land derived iron brought to the basins, kept in solution in reducing environment and got deposited in the container shelf. This is the sea level. When it became, the environment became oxygen rich, oxygenated environment, the deposition took place in form of layers with rhythmic precipitation of iron silica that gave rise to lake superior type. And in case of algon type, volcanism took place, hydrothermal fluid through hydrothermal vents are released into the sedimentary basin in annexing environment, and when the environment became oxic in the container shelves because of the organic activity, these iron they got precipitated here in form of ferric iron. So they gave rise to argon type of deposit that took place in Archean time. So this is all about the Archean and Precambrian deposits of iron in the sedimentary environments. And now let us discuss what is the SEDEX type. This is sedimentary exhalative deposit where there is association of the hydrothermal fluid in giving rise to the sulfides which are not iron sulfides. Iron sulfides gave rise to iron ore deposits. But in case of SEDEX deposit, we have the sulfides in the same hydrothermal fluid that reacts with the sedimentary environment in the ocean basins, and this hydrothermal fluid is exhaled or is erupted into the clastic sedimentary basins and the surrounding country rock. And the tectonic sheeting where these deposits are found to develop at the intracratonic basins, rift zones, passive continental margins, marginal basins. Here the host rocks are sedimentary rocks such as shale, siltstone, chert, carbonate rocks and black shells. Into these rocks, the hydrothermal fluid is found to be erupted and it intermixed with the sediments and gave rise to the lead, zinc, iron sulfides such as galena, sphalerite, pyrite, pyrrhotite. And here we can say it took place at a lower temperature, and it is same like that of the algon type, but here there is no deposit of iron. So it is the deposition of lead, zinc, sulfides. There we find in case of iron we find the deposition of oxides. Here we find the sulfides mostly lead and zinc sulfides, and it is similar to algama type, but it is not iron rich. It is sulfides. Sulfide mineral deposits took place in the same way as the algama type took place. Origin of iron took place in algama type. The origin involves the basinal brines or the aqueous saline solution containing salts and metals, which leach the metals from the basement rocks or volcanic rocks. So the basinal brine that enters into the volcanic rocks through cracks leach the metal components from the basaltic rocks. These fluids migrate upward along the faults and discharge their contents into the sea floor as hydrothermal exhalations. So the temperature of the fluid is found to be between 150 degree to 300 degree centigrade. So at a lower temperature, mixing of this hot fluid with cold seawater facilitates precipitation of metal sulfides. These sulfides get buried in the sedimentary layers through diagenesis and form stratabound or stratiform sulfide deposits. Lead and zinc deposits of Rajasthan, example. So this is like that of the algama type, but it involves mostly the deposition from basinal brines, which leaches the metals from the volcanic rocks because of the percolation into the lower basaltic rocks through the cracks and removal of these metals. So the solution becomes further rich in metals, and this metal is erupted into the sea floor as hydrothermal exhalations. It mixes with the sedimentary rocks, and there it gives rise to precipitation of different types of sulfides. And thus they are associated with the sedimentary rocks. These deposits are associated with the shale, siltstone, chalk, carbonate rocks. So in sedimentary environment, these sulfides are found to be deposited, and they form because they form from the exhalations of the fluid. That's why the deposit is described as sedimentary exhalative deposit. It is similar to that of the algama type, where iron deposit is found to be the main deposit in form of oxides. Here we find the sulfides. Then MVT type in Mississippi Valley type. This is a case which is not involved with magmatic activity. Here the sulfides are produced by sedimentation process. So this type of deposit does not require any external heat source for its formation, and it was as it was found in case of SIDEX type and algama type, where the external heat source or magmatic source was there involving sedimentation, involving ore formation along with sedimentary rocks. Here sedimentation process is there, but heat source is not the magmatic source. Heat source is the warm saline water percolating into the ground, and temperature is around less than 300 centigrade, that flow in pore spaces within the permeable carbonate rocks or sandstones in sedimentary basins. So percolation of the saline water, sea water, into these carbonate rocks, sandstones, and during this process it becomes hot, leaches the different metallic components, and it gives rise to precipitation of lead, zinc in limestones, dolomites during their process of transport through these carbonate rocks or sandstones. The tectonic setting for this deposit is stable tectonic platform, foreland basins, passive margins which are not related to volcanism. So the host rocks are limestones, dolstones, carbonate breccias. The ore minerals are galena, which is dominant, and sphalerite. And other minerals such as halite, sylvite, gypsum, calcium chloride, barite. These are the salts. The salts are found to be associated with this type of deposit because the salt solution here, the salt solution is the main source for chemical precipitation. Salts are precipitated along with some metallic sulfides. Sulfides are mostly galena. Low temperature sulfides, they are found to precipitate along with these salts. So temperature, the mineral deposit takes place mostly at a lower temperature range between 70 to 200 degrees centigrade, and this mode of formation of the mineral deposits or sulfides along with the salts are described as Mississippi Valley type because of their very origin in that valley. And so the MVT type, the Mississippi Valley type of the sedimentary mineral deposits involve formation of saline basinal brine. These brines migrate through permeable, faulted, jointed carbonate rocks, and these brines go deep into the cracks, and the precipitation of lead zinc sulfides take place due to mixing of this metal rich brine with the reduced sulfur fluids. Where from the sulfur is derived? The sulfur is derived from the reduction of seawater sulfates by bacterial reduction process. Bacteria is present in the seawater, they reduce the sulfates to release sulfur or hydrogen sulfide, H2S. And there occurs thermochemical reduction that produces the sulfurs or H2S, which reacts with these brines, and the pH increases in the carbonates due to the cooling, and these sulfides, these sulfurs, they react with these brines and they give rise to the deposit of sulfides generally at a lower temperature range. This is the process of origin of these Mississippi Valley type sulfides along with the salts. Example, Jawar lead zinc deposit, Rajasthan, where Sidex type and MVT type are also found. So MVT type does not involve any external heat source or magmatic source as it was found in the Sidex type, Algoma type. And beside this, there are other processes of origin of the sedimentary ores. It may be evaporation from the surface body of water, concentrating the mineral components present in the solution water to get precipitated after the evaporation of the water from the water bodies containing the salts in solution. And it takes, the evaporation process is a process of converting water into water vapor, and this evaporation rate is controlled by temperature. Higher the temperature, higher is the rate of evaporation. Source surface area, higher the surface area, faster is the evaporation rate. Wind air circulation, faster the air movement, faster is the evaporation rate. Humidity, it lowers the evaporation rate. Nature of liquid, the volatiles are present in the liquid, the evaporation becomes, if the volatiles are there, the rate of evaporation becomes rapid. Deposits are halides, gypsum, anhydrite, and it is of recent origin. Late tertiary and quaternary deposits, recent origin of these evaporites. So, Indian example, Ran of Kutch of Gujarat, the seasonal seawater flooding into the Kutch basin is allowed to evaporate and NaCl is found to be deposit or salt is found to be deposit. Similarly, in Sambol Lake, Rajasthan, NaCl deposit is found. Chilka Lake, Odisha, NaCl deposit is found. Bikaner Nagaon region, Ganganagar, Hanumangarh, Jodhpur, Barmor basin, where gypsum salts are found to be precipitated out of the aqueous salt solutions present in the sedimentary basins, in the sandy zones, in the deserts. So, evaporation process is effective over the salt solutions. So, salts are found to be precipitated through the process of evaporation. Let us discuss the biogenic deposits. It refers to the mineral accumulation that took place directly or indirectly due to the biological activity. It may be plants, it may be animals or microorganisms which play their role in developing certain economic mineral deposits. The living organisms, they extract elements from the water or sediments and precipitate them as minerals, such as the diatoms, radiolarians, sponges, they secrete silica and opal. So, that is by direct precipitation. Similarly, this accumulation of skeletal remains in the sedimentary environment gives rise to the limestones. For example, the corals, mollusks, foraminifers, their cells accumulate in the sedimentary basins and they form calcite deposit, aragonite deposit, dolomitic deposit. So, accumulation of skeletal matter of organisms that gives rise to mineral deposit. Besides these organisms or microbes, after the alter the redox conditions of the depositional environment, promoting mineral precipitation. The microorganisms, they promote the precipitation of the minerals, such as bacteria reduces the sulfates to produce hydrogen sulfide, which reacts with metals to produce sulfide minerals, as is found in case of the MVT, Mississippi Valley type. CDX type deposits promoted by role of sulfur cycle. Plant matters decay to produce coal. Marine planktons buried in anoxic conditions decay to produce petroleum. Similarly, bacterial activity decays organic matter to release phosphorus and concentrate them in order to give rise to apatite deposits. So, all these organic deposits are associated with sedimentary environments and they are found to be developed along with sedimentation process and hence can be considered to be a kind of syngenetic deposit. Occurrences: Gondwana coal, tertiary petroleum, phosphorite deposits of Mussoorie, Dehradun area, Udaipur, Rajasthan, Kadapa and Vindhyan limestones, diatomite deposit of Tamil Nadu. So, these are the organic deposits, very noted for their concentration of limestones, dolomites, and they are economically very important. So, sedimentation, these are the sedimentary processes by which the ore deposits, mostly iron in form of oxides, metals in form of sulfides, limestone, dolomites, and the salts, they are produced by sedimentation process. Now let us discuss about the metamorphic process. So metamorphism involves the origin of the ores and minerals by metamorphism. So it involves transformation of pre-existing rocks under the influence of increasing temperature and pressure conditions with depth, and that takes place in presence of chemical active fluid, which promotes the metamorphic reactions and formation of new minerals out of existing minerals. These transformations include solid state recrystallization, remobilization, and interaction with the magmatic emanations, volatiles, or with meteoric sea or groundwater. So these magmatic emanations, volatiles, they serve as the chemical active fluid that promote the metamorphic transformations. The concentration of metallic minerals and ores that takes place by above process produce mostly epigenetic ores, though the source of such metallic components and mineral matters may be syngenetic, because metamorphism involves a solid state transformation without any addition, generally without any addition from outside source or from magmatic source. If addition will be there, it will be a metasomatic process. Thus, the source of metals in metamorphic ore deposits are sedimentary rocks such as shales, banded iron formation, carbonates. So these are the primary source which get converted into metamorphic rocks. Similarly, volcanic rocks, the volatiles, magmatic or hydrothermal fluids, they provide the source. Chemical reactions that involve dehydration reactions, decarbonation reactions, dissolution, leaching, these processes they favor or they help in the metamorphic transformations. And the mechanism of ore formation in case of metamorphism are remobilization and reconcentration, metasomatism and metamorphic differentiation. These are three mechanisms through which the metals are found to be concentrated out of the pre-existing rocks and minerals under increasing temperature pressure conditions in presence of chemical active fluid. So what is remobilization? It takes place mostly in greenstone beds, which are common in Precambrian cratonic beds. The greenstones are the products of complex mixing and assimilation and interbedding of the volcanic shoots with sedimentary layers, as a result of which green colored metamorphic minerals such as chlorite, epidote, and serpentine are producing the greenstones, which are generally called as the metamorphic rocks. The world's most important mineral deposits are all found to be concentrated in these greenstone belts. They are noted for copper, chromium, nickel, gold, cobalt, silver. The structural weak planes such as shear zones, folds, faults, veins found in the greenstone belts, they become the site for the accumulation of these metallic minerals. The greenstones represent the downward basinal deposits in which peridotitic rocks are overlain successively by basaltic layers and silica igneous rocks and marine sediments. So greenstones, they form a basin, downward basin, the volcanism takes place, basalts, peridotites, basalts and acidic igneous rocks, they enter into this basin with deposition of the sediments, marine sediments. Many of these greenstones are derived from altered comatites, basalts and peridotic rocks that form at very high temperature, more than 1400 degrees centigrade. So at this high temperature range, these sedimentary rocks and these magmatic rocks, they give rise to the metamorphic rocks, and they concentrated the metals in these complex metamorphic rocks. Deposits include chromium, nickel, gold, cobalt, silver, and generally copper. These are almost all the metallic minerals which are found in large extent. They are generally confined to these greenstone belts. They owe the origin to metamorphic processes, and that takes place because of the intrusions of magmatic rocks, and the conversion takes place at a very high temperature, converting the pre-existing rocks into metamorphic rocks. Example: Kolar gold, Hutti gold deposits of Karnataka, graphites, kyanites, sillimanites of Western Ghats, Western Ghats mobile belts. So these are metamorphic origin. Graphite, kyanite, sillimanite, they are of metamorphic origin. They cannot be produced by any igneous process or sedimentary process. Here the paleolithic rocks may be converted into metamorphic rock, but the influence of increasing temperature, pressure conditions of the depth, that plays a role, or the role of magmatic intrusives into the sedimentary environments. And so greenstone belts, they represent the metamorphic rocks, and they at the storehouse of the major metallic minerals of the world. Beside these greenstone belts, we have the metasomatism that plays its role in carbonate rocks affected by magmatic intrusives. There, the metasomatism plays a very wide role. So metasomatism involves chemical reaction through the magmatic emanations intruding into the country rock. It may be carbonate bearing rock or carbonates which get easily affected by magmatic intrusives, and these skarn minerals are being produced by this process. The most common product of above process of metasomatism is skarns that result during contact metamorphism and metasomatism, which involve high-grade temperature alteration of carbonate rocks by intrusion of silicate magmas. So, due to the role of the magmas, calcites and dolomites, they release carbon dioxide and obtain SiO2 from the magma, and this process is called metasomatism. As a result of which calsilicates such as wollastonite, diopside, calcium garnets, quartz, plagopite, brucite, talc, serpentine, periclase, etc. are produced. The dissolved volatiles such as H2O, carbon dioxide, H2S, sulfur dioxide, HCl, they act as the catalyst to transport metallic ions in solution and cause their deposition in produced deposits of copper, gold, Pb, zinc, iron, molybdenum, tin, cobalt, manganese, silver. So these are the metallic minerals that are found to be produced because of the role of these volatiles which transport the metals in solution and cause their precipitation under suitable conditions. So these skarns these skarns are produced when the magmatic emanations, magmatic intrusives intrude into the carbonate rocks. But all skarns are not the product of carbonate rocks. There are exoskarns that develop in sedimentary rocks or limestones, and the endoskarns that develop in the igneous rocks. The modern skarns form geothermal systems or hot springs, hydrothermal vents on ocean floor, and convergent divergent margins of the lithospheric plates, and thus are found to be associated with the VMS deposits. So these are endoskarns, pegmatites, porphyry deposits and veins. These can be called as igneous origin. So exoskarn is of sedimentary origin. So the metasomatism that takes place due to the role of magmatic intrusion into the carbonate rocks gives rise to different types of calc silicates, and it also releases the volatiles which play their role in precipitation of major metallic minerals such as gold, silver, manganese, cobalt, tin, molybdenum, iron, zinc, lead, copper. So these are found to be precipitated because of the role of the volatiles that are liberated either from the magmatic intrusives or because of the reaction with the carbonate rocks. Carbon dioxide is released, and because of dehydration reaction H2O is released. So volatiles become potent to carry out the metamorphic transformations and precipitation of metallic mineral in the metamorphic rocks. So metasomatism plays a role particularly in carbonate rocks to give rise to equinominal deposits, and the greenstones, they play their role in formation of metallic mineral deposits in the metamorphic environment. So these are the two major sources of origin of minerals, ores in metamorphic environments. Besides these, we have the metamorphic differentiation, which also plays a role in formation of banded iron formations. Banded iron group of rocks. It involves mineral segregations during recrystallization. Here dense ore minerals are found to get concentrated in bands. Banded iron formation. Banded iron enrichment process involves segregations of iron by metamorphic reactions. So it is major process of metamorphic origin is the metasomatic process involving the carbonates which concentrate metallic deposits, and also the greenstones which look at the metallic deposits. World's most equinominal deposits are associated with these greenstone belts in the metamorphic environments. So this is all about the different processes of origin of mineral deposits that we see to be distributed over the earth in different environments. The environments are igneous environment, sedimentary environment, and metamorphic environment. But the main source that can be said is the igneous source, which serves as the primary source, and from that we can get the sedimentary formations which are derived from the original igneous source. And similarly, the metamorphic rocks, they owe their origin to the temperature pressure conditions at depth in presence of the chemical active fluid, and this fluid may be derived from the magmatic sources or through different types of reactions that takes place at the subsurface, by which the chemical fluid is released to carry out metamorphic transformation and concentrate the mineral deposits under suitable conditions. So this is all about what I wanted to discuss. Thank you all for giving a patient hearing to my talk.